So do we come up with an area? What was the area that we came up with? An area of, again, 4 times 1, because it's the area of a rectangle, so we should come up with an area of 4. So any questions on that one? All right, you guys go ahead and do this. Try and do the sketch for letter C for me. So go ahead and try and sketch this one for me and see what you guys come up with. Did we all come up with this sketch right here from -3 to 3? Any thoughts on what shapes you could divide this into? How can you divide it up? You can divide it up into what? Triangle and a rectangle. So we already have this going all the way. We can just go ahead and continue that line of y equals 1 out to -3 to +3. So now what I can do is I can calculate the area of the rectangle and go ahead and add it to the area of the triangle. So you guys go ahead and finish that and go ahead and calculate that particular area for me and add them together. Everybody come up with the area of the triangle to be 6. Because base is 3, and then the height is going to be, remember this is at 1, this point's up here at 5, so the height is going to be 4. Then the area of the rectangle is going to be 6 times 1, which is 6. Again, your base is 6, and then your height is just 1. So you end up with 6 plus, so the total area is going to be 6 plus 6, which is 12. So any questions on C? So like I said, some regions you have to, what, did I do something wrong? Oh, did I put that wrong point? I can't do math today. At -3, you're right, it should be up here at 7. Thank you. My fault. My fault. You're right, that is at 7. So that's certainly going to change the area of the triangle. So that's going to be a height of 6. That becomes a 6. So let's see, 6, 18, 9. So then 9 plus 6 is 15. Thank you. Sorry about that. I don't know where I got the 5 from. All right, you guys go ahead and do D for me. Go ahead and see if you can sketch the picture for letter D. See, they're all bringing their federal survey forms. They really want that piece of money. I'm starting to get worried. I know it does. Ugh. Now I'm paranoid. Did we all come up with an area of 10? That's where the 5 came from. Maybe I was looking at the wrong, I don't know. So we came up with an area. The area of the triangle is 4, and the area of the rectangle is 6. So any questions on how you can do the sketches and then calculate the area using the appropriate geometry formulas? So sometimes instead of you having to come up with a sketch, they'll actually give you the graph itself. So here's an example of some curve, and they're actually telling you what the area underneath each curve is going to be. So for your region from A to B, what are they telling you about the area under the curve? The area is what? So from your interval A to B, what's that closed area? What's that area going to be? 10. From B to C, now be careful because this region is not above the x-axis. This region is falling below the x-axis. So what do we know about this area below the x-axis? It's not going to be positive 94, but it's going to be what? Negative 94. So now from A to C. So again, remember what you can do is just simply add those areas together. So I can take the area under the curve from A to B of f of x dx, add it, the area under the curve from B to C of f of x dx. So we already told me that the area under the curve from A to B was 10, plus the area under the curve from B to C was negative 94. So this area is going to turn out to be negative 84. So any questions on that? You guys go ahead and do D for me on your own. So did we all get negative 75? Okay. So let's take a look at another type of, instead of me giving a picture, now they're actually telling you what the area of each definite integral is going to be. So they want us to find the area under the curve from -1 to 6. Well, what's the problem with the bounds right here? The bounds are what? The bounds are in place going from -1 to 6, but take a look at this one right here. It's going from 2 to -1. Remember what I said about this lower bound? This lower bound should be what? Should be your smaller one. Should be your smaller one. So in other words, to rewrite this so that it's a proper integral, you're going to want to negate it. So we want to find the area under the curve from -1 to 6 of f of x dx. So that's going to have to be equal to the area under the curve, the negative, again I'm going to negate this from -1 to 2, of f of x dx, plus the area under the curve going from 2 to 6. So when you flip those bounds, you just want to negate the area. So they told us that the area from 2 to -1 is 7. So then this is going to have to be a -7. Plus, they told us the area under the curve from 2 to 6 is 5. So the area under the curve for the entire area, the -1 to 6 of f of x dx, is simply going to be a -2. So any questions on A? Let's take a look at B. They want us to find the area under the curve from 0 to 6. If the area from 10 to 0 is -4 and from 6 to 10 is 8. So first of all, notice your antiderivative from 10 to 0 is the total region, and they're telling us the total. So again, I have to negate this, so I know that your area under the curve from 0 to 10 of f of x dx has to be equal to the area under the curve from 0 to 6 of f of x dx plus the area under the curve from 6 to 10 of f of x dx. So any questions on how I've set this up? So now plug in the values that they're telling you about the areas. They're telling us the area under the curve from 10 to 0 is -4, but when I negate that, that's going to be 4. 4 has to be equal to, again, I'm trying to figure out the area under the curve from 0 to 6. Plus, they're telling me the area under the curve from 6 to 10 is 8. So now how am I going to solve for the area under the curve from 0 to 6? I'm simply going to do what? Subtract your 8. So then the area from 0 to 6 of f of x dx is simply going to be -4. So any questions on that? All right. So like I mentioned, guys, today's lesson was pretty short. So like I said, that's it for today.